Hi, guys. All right. Happy Monday. Chapter 2, moving forward. Hopefully the test went okay. Today I will submit grades for progress reports and conduct grades. We're moving along. Okay, so we're going to move into section 2.1. And again, I always recommend that you guys read the textbook. It's super helpful, gives you some context. But the notes they should do the trick as well. So we're going to talk about what a percentile is, and you guys might have heard about this if you've taken a test like an SAT or something. You get your score back, and you're in the 85th percentile. Well, all that means is that p percent. So if you're in the 85th percentile, 85% of the observations are at or below you. Okay, and so it's pretty simple to create percentiles or to find them. So down here you can see that we did a stem plot, and after chapter 1 we know what that is. This is a stem plot that shows the number of wins for each of the 30 Major League Baseball teams in 2012, so 8 years ago. And it tells us our key here, 6/1 represents a team with 61 wins. Okay. All right. So simple math here. We are going to find the percentile for the two teams. So let's do the Minnesota Twins first, who won 66 games. Okay. So we're going to come up here to 66, which is right there. And to find the percentile, we want to know how many values are at that value or below it. And so if you start counting with the dot, like that's one value because we're there. 1, 2, 3, 4. So there are 4 values at or below 66. So you would say that the percentile is simply 4 out of a total, right, of 30 teams, which is obviously a little bit more than 10%. It comes out to 13.3%. Okay. So the Minnesota Twins were in the 13th, basically, it's around 13th percentile, which is not good, right? There are only 13% of the teams in the league that are that many wins or below it. Okay. Now the Washington Nationals, who have 98, right? Well, 98 is all the way up. Yeah. So how many values are at or below it? 30 out of 30. So they are in the 100th percentile. Okay. All right, so simple stuff. To find a percentile, just go to the value and find how many values are at or below it. Divide that by your total, and you're good to go. All right, so another way that this shows up in statistics is it's called a cumulative relative frequency graph. Sometimes it's called like an ogive graph. It doesn't really matter. So let's just look at the axes and try to figure out what's happening. So we're going to talk about a graph that is showing the distribution of median household incomes for the 50 states and the District of Columbia. Okay, so California with a median household income of this, right, is at what percentile? And interpret this value. Okay, so let's review because we got a lot of vocab here. So what's up with median? Median is talking about that number, 57,445. 50% of families in California make more than that, and 50% of families in California make less than that. And so if you want to go over to the graph along the x-axis, you can see that it's talking about the median household income. And then over here, you have your cumulative relative frequency, but that's just fancy, you guys. These are percents. Okay, so you can very quickly find your percentile. So if you go to 57,400, there's 55, there's 57.5. So we're right about there. And so what you guys should do is you go to the value that they give you. It's not a percent. This is a median household income. And you draw a straight line up to your cumulative relative frequency graph. And then when you get there, you go straight over, right? Create your box and go straight over to find your percent. And it's super easy to see right there. You're at the 80th percentile. So what percentile? You're at the 80th percentile. And what does that mean? Interpret the value. So you would say 80% of states have at or below a median household income of $57,445. Okay, so this graph was really easy. We went into the median household income, we went up to the graph and over to the y-axis, which is your percentile, and we were right at 80.8, which is 80th percentile. And what that means is that 80% of all other states, right, have a lower median household income. Okay, so we could do the opposite, right? We could say, well, then let's find the 25th percentile. So now you're given a percentile and you're trying to find, right, the median household income. So now, right, I'll do it in a different color. You're starting, this is 0.3, so you're starting right here, right, at 0.25. And now what you're going to do is you're going to go over to the graph from the y-axis, but then down, and that's your answer. Okay, so the 25th percentile relates to a median household income of $45,000. Okay. So again, the 25th percentile, which means 25% of all states have a median household income of $45,000 or below. Okay. All right, so we've talked about percentiles. We've talked about this cumulative relative frequency graph, which you can find percentiles of certain values or go backwards, given a percentile, find where that value exists. And then we're moving into this last little part today before I show you the homework is how do you get like a standardized score? Okay, so we'll talk a lot in statistics about heights, we'll talk about incomes, and they're all different things. And so what we want to do is we want to standardize those values so that we can just talk generically about, right? Once it's standardized, it tells you how many standard deviations away from the average is it, right? So let me give you a basic concept here. I teach AP calculus, and let's say Jenny's in my class, and Jenny gets. So let me give you a visual because I know you guys are listening to this. So Carpenter teaches AP Calc, and I teach Stats 1C. Okay, and let's say Jenny's in my class for both of them. And on this test, she gets an 83%, and in Stats, she gets a 90%. Right? She goes home to her parents, right? Jenny says, hey, here's my scores from Calc, AP Calc, and College Prep Stats. Jenny's parents are going to look at this probably, unless they're highly, highly educated in statistics, right? Because most of us, there's nothing wrong with this. Most people will be like, hey, she's better at stats than she is at calculus. Well, that's relative, you guys. You have to be careful. What if everyone in stats class got a 98%? Jenny underperformed. What if everybody in calculus got lower than her? What if that's the highest score in the AP Calc class? Jenny could be ridiculously good at AP Calculus, even though you compare these two to each other and they're different scores. Relative to the class, it could be different. And so that's this whole idea of standardizing a score is comparing it to the data that it has. And it's really easy. We're going to find a standardized score, which is this Z value. And all you have to do is take the score, subtract the average, and divide by the standard deviation. And what does it do? It tells you how many standard deviations away from the mean and which way, right? Are we higher than the mean or lower than the mean? Okay, so let's look at this example here. So 2012, the mean number of wins for this Major League Baseball was 81 with a standard deviation of 11.9. Okay, so out of all of the teams, right, the average was 81 wins with a standard deviation of 11.9. How did the New York Yankees do? So let's standardize it. So again, we have an X value, a data point of 95. To standardize it, all you have to do is follow this simple formula. You take that value, you subtract the average, and you divide by the standard deviation. Okay, so you grab your calculator, you take 95, you subtract 81, hit enter, right, first, and then divide by 11.9, and you get 1.1, we'll just go to 2 decimals, 1.18. Okay? All right, so what does that mean? It tells you, right, the Yankees, just copy this sentence, right? The Yankees were 1.18 standard deviations above the average. How do I know above? Above, it's because it was positive 1.18, right? If it was negative, we would switch this word to be below. Okay? All right, well, now let's check the Mets. Okay, so the New York Mets has an X value of 74. Well, to get a Z-score, you take that value, 74, you subtract the average, which is 81, and you divide by the standard deviation. Okay, same issue. You take 74, you subtract your average, you divide by your standard deviation, and you get a negative value this time, negative 0.59. Right, so the Mets were 0.59 standard deviations below, right? So this standardized score, this Z-score, right? This is your Z-score. Okay, here's your Z-score. It tells you two things, you guys. How many standard deviations and in what direction. How many standard deviations and in what direction. Okay. All right, so on the next page, okay, this is, I'm going to summarize this so that the video doesn't get too long. But you can see here that, there's different baseball players over the years. Back in 1927, right, Babe Ruth hit 60 home runs. Okay. Well, right, up here in 2001, Barry Bonds hit 73. And so if you just look at these numbers, you're like, well, Barry Bonds is better than Babe Ruth. Well, hold on a second. You have to compare Babe Ruth to other players in 1927. That's messed up, right? People over time have gotten bigger, stronger. They're personal trainers. All these things have to be taken into account. So you have to compare, right, Babe Ruth and Barry Bonds to the year that they played baseball because things change. Okay, so I'm not going to do all four of these, but let's just compare Babe Ruth, because I brought it up, and Barry. Okay, so let's do it. Let's take the number of home runs that Babe Ruth got, 60, and let's subtract the average, which is 7.2, and divide by the standard deviation, which is 9.7. So if I take 60 and I subtract 7.2, hit enter, and then divide by 9.7, I get 5.44. And if I take Barry Bonds, who had 73 home runs, subtract the average, and divide by the standard deviation, you get 73 minus 21.4, hit enter, then divide by 13.2, and you get 3.9. Okay, so what's your conclusion? Well, this compared to that, this is bigger. So Babe Ruth was 5.4 standard deviations above the mean, and Barry Bonds, relative to his teammates, to all the people in the league in 2001, was only 3.9. So you would say, compared to the year these players played in the major MLB, Major League Baseball League, okay, Babe Ruth performed better because, how come? Because he was further to the right of the mean. Okay? And so your standardized score takes data points that are really hard to compare because there's so many other things that come into play, right? And it standardizes it, and it tells you, look, this guy was so good, he was way above the average for that year. Barry was also good. He was above the average for that year. But because Babe Ruth was further away from the average, right, in a positive direction than Barry Bonds was, you would conclude that Babe Ruth did better. Go back to my Jenny, right, example. What if these were the numbers for Jenny in AP Calc and Jenny in College Prep Stats? We made the decision just by looking at this that Jenny's better at stats because she got an A- versus a B. But when you compare it to the class, if these numbers were with my example, we would say, hey, Jenny's better at AP Calculus because she's performing better compared to the students that are there. Okay. All right, you guys. So this chapter will get a little bit more mathematical, but nothing crazy. Make sure and stay up on your assignments, right? We're at chapter 2 now, right? The expectation is you guys check into Schoology every single day. You look for the folders that are labeled, and you stay up on your work, okay? All right. Take care, you guys.